Hello everyone. Today we are going to start semantics of first order logic, and we are going to work on handout 13 that involves problems where we determine the truth value of a sentence on a given interpretation. So let's start by talking about interpretations in first order logic. So here we have a bunch of sentences on the right, and we want to determine the truth value of them on this interpretation on the left. So an interpretation in first order logic consists of these elements. First, we need to have a domain, and the domain can include any objects. But in this class, our domains always involve numbers, so we put numbers in the domain as objects. So on this interpretation, the first element here, the domain involves three objects, 1, 2, and 3. So we treat these numbers as objects, or you can think of them as object 1, object 2, object 3. The second element of an interpretation, if you're interpreting interpreting sentences that involve names, like the sentences that we have on the right, then you need to assign object to those names. So here we assign object 1 to object 1a, we assign to object b 2b, and we assign to object 3 c. So basically we are saying that the name of object 1 is a on this interpretation. You can assign any name to any object. Again, this is a given interpretation, so in this one the names are assigned this way. So for example, you can think of a as Adam, so we're saying that object 1 is Adam, object 2 is Betty, object 3 is Sid, right? So we assign names to objects in the domain. And the last element is that we assign extension to predicates. And here we have a bunch of predicates with extensions assigned to them. So here we have, for example, W, which is a one-place predicate, and what we have here is the extension of W. So we are basically saying that object 1 and object 3 are W. So if you think of W as Y's, so we are saying that object 1 is Y's and object 3 is Y's. Now again, you can assign any extension to W using the objects that are in the domain. So for example, you can assign 2 to W if you want to, but this is the given interpretation that we are working with. So the extension of a one-place predicate is just a set of objects from the domain. G is another one-place predicate, and as you see, there is no extension for G, which basically means that nothing is G. So for example, if you think of G as grateful, none of the objects in the domain are grateful. So the extension of G is empty. Then we have two-place predicates, L and R, and the extension of two-place predicates are ordered pairs. So for example, we can think of L as love, and what this extension here is telling us is that 2 loves 3, right? So if Betty loves Sid, 2 also loves 2, Betty loves herself, for example, and 3 loves 1, so C loves A, right? And these are called ordered pairs because the order matters. So 2 loves 3, but 3 doesn't love 2, according to this interpretation. Then we have R, respect, for example. So we're saying that 2 respects 2 and 3 respects 2 on this interpretation. Now we can put any kind of number that we want in the domain. We can assign names any way that we want, and we can also assign predicates any way that we want. So there are other interpretations. For example, here we have another interpretation. Here again, the domain involves 3 objects, but the names are assigned differently, and also the predicates have different extensions. This is another interpretation for the same statements that we have on the right. Okay. Now, how many interpretations can we have? Well, really, it's infinite, because you can put any object in the domain. You can assign predicates any way that you want to. You can assign names any way that you want to. So you have basically infinite number of interpretations. So now here, for practice, we want to determine the truth value of sentences on the right using the interpretations that we have on the left. And we have two interpretations on the left. So let's start with the first interpretation. Let's see how we determine the truth value. So here we have sentence 1, we have a conjunction, WA and RBC. So we need to know the truth value of each conjunct in order to determine the truth value of the conjunction. So WA is saying that A is W. If you look at this interpretation, A is the name of object 1, and object 1 is in the extension of W. So it is true that A is W on this interpretation. So it is true here. Now let's look at RBC. So B is the name of object 2, and C is the name of object 3. Okay, and if you look here in the extension of R, you see that we don't have the ordered pair 2, 3, right? That is not included in the extension of R. In other words, B doesn't respect C according to this interpretation. So RBC is going to be false. So the truth value of the entire sentence is going to be false because one of the conjuncts is false. Okay, let's deal with this one. This one is a conditional. So the truth value of the first part, LBC. So again, B is 2, C is 3. So notice that 2, 3, this ordered pair is in the extension of L. So it is true that B loves C. How about this one, GB? Well, B refers to 2, so is 2 in the extension of G? No, nothing is in the extension of G. So GB is going to be false. And true arrow false gives us false again. So here, is object 3 in the extension of W? Yes. So this is true. Is 2 in the extension of L? Yes. So this is true as well. So the entire thing is going to be true. And the last one, RAB. So A is the name of 1, B is the name of 2. And as you can see, 1, 2 is not in the extension of R. So this one is going to be false. And that makes the entire conjunction false. Okay, so let's deal with this one, RBC. Is 2, 3 in the extension of R? No. So RBC is also false. So false or false gives us false. Okay. So those are the truth values of statements on this interpretation. Now we can try a different interpretation with the same statements. So these are the same statements on the right, but the interpretation is different. Now let's try to determine the truth value of those statements on this new interpretation. So here the names are assigned differently. So A is the name of object 2 on this interpretation. B is the name of object 1 and C is the name of object 3. Okay, so WA, since A is the name of object 2, the question is whether 2 is in the extension of W. And if you look here, 2 is not in the extension of W. So this is going to be false. And that is enough to make the entire thing false, because that's a conjunction. So here, B is object 1, remember? C is the name of object 3. So is 1, 3 in the extension of L? Yes. So this is true. How about GB? Again, B is object 1. So is 1 in the extension of G? No. So GB is going to be false. True to false gives us false. Okay, WC. So C is the name of object 3. Is 3 in the extension of W? Yes. So this is true. LBB. Okay, B is object 1. So the question is 1, 1 in the extension of L? And as you can see, there is no such thing in the extension of L. So LBB is going to be false. So the whole thing is going to be false. Okay, let's do the last one. RAB. So A is name of 2, B is the name of 1. So is 2 1 in the extension of R? Nope. So this is false, and that makes the entire conjunction here false. How about RBC? Is 1 3 in the extension of R? Again, no. So that is false as well. So the whole thing is going to be false. So that's how we determine the truth values of statements that do not involve predicates. Now you can have other interpretations, and you can try to determine the truth value of these statements on those interpretations as well. But I'm going to stop here. Now let's talk about an alternative representation of interpretations. So when you have an interpretation that involves only one place predicates, then you can represent that interpretation in a matrix format. So what we have here on the left are two interpretations of, let's say, the statement WA and WB. Sorry, WA and HB. Let's consider this statement. Here what we have in these matrices are two interpretations of this statement. So basically this matrix is telling us that A is the name of object 1. First of all, it's telling us that the interpretation involves 3 objects. So the domain of the interpretation is 1, 2, 3. Right? We can read all this information from the matrix. And then it is telling us that A is the name of object 1, B is the name of object 2, C is the name of object 3. And it's also telling us that object 1 and object 3 are in the extension of H, but object 2 is not. And also it's telling us that object 3 is in the extension of W, but object 1 and 2 are not. So that's basically what we have in the matrix is an interpretation, but it's kind of represented graphically. Okay, you can do the same thing with the second matrix, but you don't really need to translate matrix into this kind of presentation of an interpretation. You can just work directly with the matrix, right? So on the first interpretation, WA is false because object 1 is not in the extension of W. And HB is also false because object 2 is not in the extension of H. And the whole thing is false. Now we can do the same thing with this interpretation here. So this time the domain involves only 2 objects, and B is the name of object 1, A is the name of object 2. Okay, so since A is the name of object 2, the question is whether object 2 is in the extension of W. Notice that it is not. So again, this is going to be false. How about this one? Is object 1 in the extension of H? Yes, it is. So this is going to be true, but the whole thing is going to be false. Okay? So for the most part, we're going to represent interpretations that involve one place predicate as matrices because it's easier to read them. Okay, now let's talk about determining truth value of statements that involve predicates. Sorry, that involve not only predicates but also quantifiers. So here we have an interpretation in this matrix. And notice that we are not assigning any names to the objects in the domain because the statements that we are interpreting 1, 2, and 3 here, they don't involve any names. So in our interpretation, we do not need to assign names to these objects. Okay, so here we have an interpretation of these statements that involve only one place predicates. So how should we determine the truth value of these? Quantify the statements. So notice that the first one is telling us that there is some object in the domain such that it is not F, but it is G, right? So if you look at this domain here, this interpretation, you see that there is an object in the domain, namely object 2, that is not F, but is G, right? So it is true that there is some object in the domain that is not F, but is G. So this thing is true, and you can determine that by just looking at the interpretation. But we need to have an approach that works not only for the simple statements like this, but also for the more complex statements. So let's talk about that approach. So when we are dealing with this statement, we are saying there is some x such that x is this, right? There is some x such that this thing is true of that object, right? So since we have only two objects, the question is that whether this thing is true of object 1 and whether this thing is true of object 2, right? And the way that we show that is in this way. So you eliminate the quantifier, and then you have there is not fx and gx. Now we are asking whether this thing is true of object 1 and whether this thing is true of object 2, right? So we are treating x as referring to object 1, and then we are treating x as referring to object 2. So here, if x is referring to object 1 is f. So the negation of it is going to be false. So the whole thing is going to be false. But here, since x is referring to object 2 and object 2 is not f, then fx is going to be false and the negation of it is going to be true. Then we move here. Object 2 is in the extension of g, so if x referring to 2, gx is going to be true. True and true gives us true. So we say that since it is true of at least one object, in this case namely object 2, that's not f and g, therefore there is something that is not f and it is g. So because this one is true, this is going to be true, right? So this is how we approach things when we have an existential. We want to know whether there is an object that satisfies this thing in the box, right? So here in the first part, we are asking whether object 1 satisfies the thing in the box, and the answer is no. And then we are asking whether object 2 satisfies the thing in the box, and the answer is yes. And as long as there is one thing that satisfies that thing in the box, the existential is going to be true, right? Okay, now in the next statement, we are dealing with a universal. So we are saying that everything is such that it is not f and it is g. Again, you can easily determine whether this is true or not by looking at the interpretation, because this is a very simple statement. It is saying that everything is not f but it is g. But as you can see in this interpretation, we have an object 1 which is f and g. So it is not true that everything is not f and g. So you know that it is going to be false, right? Just by looking at the interpretation. But again, since we are trying to develop an approach that works for more complex statements, let's just try to calculate the truth value in a systematic way, as we did with the first one. So here, since we have a universal, the claim is that for all x, this thing is true, right? So we want to see whether that is true. So we ask, is this thing in the box true of object 1? and then we ask whether that thing is true of object 2. So here we are treating x as referring to object 1. So if we do that, fx, if x is object 1, is true. So the negation of it is going to be false, right? We don't need to calculate the rest of it really, but if you want to, this is true because 1 is in the extension of G, and false and true gives us false. So that's basically enough at this point in order to give us the truth value of the universal, because the universal is the claim that this thing in the box is true of every object, or every object satisfies this thing in the box. And we just saw that object 1 does not satisfy the thing in the box. So that is enough to make this universal false, right? So this is how I show it. Since this is false, the universal is going to be false. We don't even need to know the truth value of this second thing. Obviously, we know that it is true, but it doesn't really change any fact here about the truth value of the universal. Okay, let's do the same thing with number 3. So we want to determine the truth value of this on this interpretation, and here the claim is that for all x, x satisfies this thing in the box. Okay, let's see if that is true. So we have two objects here. So we're going to get fx when x refers to 1, arrow gx when x refers to 1, and then we're going to have fx when x refers to 2, and gx arrow gx when x refers to 2. Now the question is whether these things are true, because for the universal to be true, both of these things need to be true. Okay, so fx1 is true because of this. Gx1 is also true, so this thing is going to be true. Good. But that is not enough to make the universal true, because universal is claiming that the thing in the box is true for every object, right? So let's see if object 2 also satisfies it. So fx2 is false if it's referring to object 2. Object 2 is not f, so this is going to be false. And that is enough to make this whole conditional true. Okay, now notice that for every object in the domain, namely object 1 and object 2, the thing in the box is true. So every object satisfies the thing in the box. Therefore, the universal is true, right? And the way that we show it is that we say since these things are true, then the universal is going to be true. Of course, for these simple things, you don't really need to do this in order to determine the truth value, because 3 is the claim that everything that is f is g. And if you look at the matrix, you see that everything that is f is g, because there is only one thing that is f, namely object 1, and that is also g. But you need to prove, you need to show that you know why that's the case. So we do this little diagrams in order to show our solution. Also, when the problems get complicated, you need to approach it in this way by drawing diagrams. It's not always easy to see whether the statements are true or false just by looking at the interpretation. Okay, so now we are going to do some more complex sentences, but before we do that, let's just review what we kind of intuitively were drawing upon here. So we're saying that an existential, for example, there is some ax, where a could be any formula, is true on an interpretation if and only if at least one object in the domain satisfies ax, right? So going back, this existential in number 1 is true because there is at least one object that satisfies this whole thing that is going to be our ax, right? And that object is object 2. So for an existential to be true, we need to have at least one object that satisfies ax. Then we say that a universal for all x ax is true on an interpretation if and only if every object in the domain satisfies AX, right? So going back, look at sentence 3. Here AX is this whole thing in the box, right? And the universal is true because every object in the domain satisfies the thing in the box. Object 1 does and object 2 does. So the universal is true. But in sentence 2, there is one object that doesn't satisfy the thing in the box, namely object 1. So the universal is not going to be true. So that's the idea. For an existential to be true, you need to have at least one object that satisfies AX, and for a universal, for all AX to be true, you need to have a case where every object satisfies AX. Okay, so let's do some more interesting, complicated statements. So here we have this interpretation at the top, and we want to determine the truth value of this sentence on this interpretation. So the first step is to determine what kind of statement we are dealing with. And if you look at this statement, you see that we have a universal, and the scope of the universal extends to here. So everything is in the scope of a universal. So we are dealing with a universal statement. Now, we know that a universal is true if every object in the domain satisfies the thing that is in the scope of the universal. So the question is that whether every object in the domain satisfies this thing that is in the box. Okay. So there are 3 objects in the domain, so we need to check 3 things. So the first is that we get f, x, and hx arrow jx if x refers to object 1. So what's the truth value of that? Well, 1 is in the extension of f, right? So this is true. H has 1 in its extension, so this is also true. So this whole thing is true. 1 is also in the extension of j, so this is true. So this whole thing is true, okay? So the first object satisfies the thing in the box. Now, that is not enough to make the universal true. Every object needs to satisfy the thing in the box. So we move to the second object. Does the second object satisfies the thing in the box? So we're going to have fx, this time x refers to object 2, and hx, where x refers to object 2, arrow jx 2. So let's see. Well, object 2, as you can see here, is in the extension of f, so this is going to be true. It's also in the extension of h, so this is going to be true. So the whole antecedent is going to be true. But x is not, if x2 or object 2 is not in the extension of j, as you can see here. So this is going to be false, and true arrow false gives us false. So as you can see, it's not the case that every object in the domain satisfies the thing in the box. So the universal is going to be false. And why is false? Because, well, here we have one object at least that does not satisfy the universal. We do not need to check object 3 because it doesn't make any difference. Even if it is true for object 3, still the universal is going to be false, right? Because not every object satisfies the thing in the box. Okay. Let's do this one. So it's a good idea that you pause the video and try these problems for yourself, and then you can check your answers with me. So here we have an existential right? So the first step, remember, is to determine the kind of sentence that you are dealing with. And here we are dealing with an existential because we have this existential and then the scope of it extends to here. So everything is in the scope of the existential statement. So now the question is, since we are dealing with an existential, if there is at least one thing that satisfies the thing in the box, then the existential is going to be true. So we want to know whether that's the case. So let's start with object 1. So fx when x refers to 1 and for all y jy when y. Okay, so that's the whole thing. So you eliminate the main quantifier and then you treat x as referring to 1. Now the question is this thing true? Well, notice that the thing that we have here now is a conjunction. This is the main connective. So it is true if both of these conjuncts, this one and this one, are true. So let's see if that's the case. So fx1 is true because 1 is in the extension of f. Now the question is that is for all y jy true? Well, now again we have a quantified statement, it's a universal, and we know that a universal is true if everything satisfies the thing in its scope. So if everything satisfies j, then the universal is going to be true, right? So the question is that does everything satisfy j, right? So there are three things. The first object j referring to, if y refers to 1, is true. J if y refers to 2 is false. And that is enough to make the universal false, because the claim that we are dealing with here is that everything is j, and as you can see, not every object satisfies that. For example, here object 2 does not satisfy the thing that is in the scope of the universal. So this thing is going to be false, and the reason that it is false is that there is at least one thing that doesn't satisfy it. Of course, we can check j y when y refers to 3, but that is not going to make any difference. Okay, so what's the truth value of this whole conjunction here? True and false gives us false. So remember, we are trying to determine the truth value of this existential, and as it turns out, object 1 does not satisfy the thing in the box. Okay, but as long as there is something that satisfies the thing in the box, the existential is going to be true, so we need to keep going. Now the question is, does object 2 satisfies the thing in the box? So the question is whether fx2 and for all y jy is true. Okay, again the same deal. We have here a conjunction, so the truth value is determined by the truth value of this part and also this part. And from the previous step, we know that for all y jy is false, right? It is not the case that everything is j, because if you look at this interpretation, 2 is not j, right? So we already know that this is false, so this whole thing is going to be false. So object 2 does not satisfy the thing in the box either, and you can easily see that object 3 doesn't satisfy it either. But for our solution to be complete, we need to show that, right? We cannot just stop here. We need to show that nothing satisfies the thing in the box. So we go check object 3 as well. And again, regardless of what fx3 is, we know that this is false from the previous steps. So the conjunction is going to be false. So there are 3 objects in the domain, and none of them satisfies the thing in the box. So we know that the existential is going to be false. Now that we have checked everything, we can say yes, the existential is false. And we show that by doing this. Since all of these things are false, that makes the existential false, right? So if you leave out like the last step, like this one here, your solution is not complete because you cannot claim that an existential is false unless you have checked every object and you have shown that every object fails to satisfy the thing in the box, right? Okay, let's try this one. The same interpretation, a different statement. Now, the first step, as always, is to check what kind of a statement you are dealing with. And if you look at the statement that you have here, you are dealing with a negation because this is the negation here is the main connective, right? So since you are dealing with a negation, the truth value of this statement is the opposite of the truth value of the thing that is being negated, namely there is some x, fx, and not a, ix, right? Whatever the truth value of the existential, the truth value of the negation is going to be the opposite of that, right? So what we need to do is that first we need to determine the truth value of this existential. Namely, there is some x, fx, and not ix. Again, this is one of those things that you can easily determine the truth value just by looking at the interpretation that you have, because the claim here is that there is something that is f but not I. And you know that this is true. For example, object 1 is f and it is not I. However, you need to present your solution, so let's do it systematically. So we want to determine the truth value of this existential, so the question is that whether there is an object that satisfies it. So let's check. So let's start with object 1, so fx1 and the negation of ix1. We want to know whether that is true. So fx1 is true. ix1 is false. So the negation of it is going to be true, and true gives us true. Well, so it turns out there is at least one object, object 1, that satisfies the existential, that satisfies the thing that is in the scope of the existential, namely this thing. Okay, so that is enough to make the existential true. So you can stop here and just say that since this one is true, that is enough to make the existential true. Okay, so now we know that the existential is true, right? So the negation of true gives us false. So this whole statement is going to be false. Okay, so don't make the mistake of trying to treat this whole thing as existential. So here is a mistake that some people might make. Sorry. So it's a mistake to do this. Let's say you do this. You say, well, I want to know whether this is true, so I want to know whether there is something that satisfies this. For example, whether object 1 satisfies this. This is a mistake because here you're dealing with a negation, and we don't talk about satisfaction of something that is in a negation. So you cannot just go ahead and eliminate the existential that sits between the negation and the rest of the sentence. So this thing, whatever the truth value of this thing is, it has nothing to do with the truth value of the statement that you're trying to determine. Okay, so it is a mistake to do something like this. You need to approach it in the correct way, which is that so you're dealing with the negation of an existential, so first determine the truth value of existential. Now that you're talking about existential, now you think about satisfaction. Is there something that satisfies the thing in the box, right? So this is a mistake, don't do that. Okay, let's move to the next one. So what kind of a statement is this? Well, notice that here we have a universal here for all x, fx, and hx. Then we have an existential here, there is some xjx, and those two things are connected through an arrow. So you are dealing with a conditional. And the truth value of conditional is determined by the truth value of its antecedent and its consequence. So let's determine the truth value of the antecedent. So I start with the antecedent. And the antecedent is for all x, fx, and hx. And we know that it is true if everything in the domain satisfies this thing in the box. So let's see if that is the case. Let's start with object 1. So we get fx1 and hx1. What's the truth value of that? Well, this is going to be true because fx1 and hx1 are both true. So let's do the object 2. Well, again, fx2 and hx2 are true, so this is going to be true. Now let's do object 3, fx3 and hx3. And here notice that hx3 is false, so this whole thing is going to be false, right? And that is enough to make the universal false. So there is something that doesn't satisfy the thing in the box. So the universal, the claim that everything satisfies the thing in the box, is going to be false. Okay. Now, again, if you look at the interpretation, you can easily see that object 3 doesn't satisfy the thing in the box. So you can just go directly to object 3 and write this one and skip this other two if you want to. Because what you need to, in order to show that this is false, is just one false instance. Okay, so the antecedent is going to be false, right? Now, what does that tell us about the truth value of the entire conditional? Well, it tells us that the entire conditional is going to be true, right? It doesn't matter what there is some xjx is. Since the antecedent is false, the whole conditional is going to be true. Okay, so again, it is important to understand that you're dealing with a conditional and the truth value of it is determined by the truth value of the antecedent and the consequence. So here is a common mistake that people make. So if you fail to realize that you are dealing with a conditional, you might think that, so this is a mistake, but you might think in this way. Well, let's see if there is any object that satisfies this formula. So you might think that, let's see if x1 satisfies this. And then you maybe x2, x3, and you continue with that. But this is a mistake because this thing here, the truth value of this thing has nothing to do with the truth value of a conditional. We don't really determine the truth value of the conditional by reading the truth value of this thing. This is just irrelevant here, right? So if you fail to see that you're dealing with a conditional, you might do things like this thing here on the right, and you won't get credit because the thing on the right, even if you determine the truth value of this thing correctly, it has nothing to do with the truth value of the statement that you're trying to determine, right? Now, if you had a statement like this for all x, fx and hx arrow jx, which is a universal, then yes, then you need to think about the truth value of this thing. You want to know whether object 1 satisfies the thing in the box, whether object 2 satisfies the thing in the box, right? But you are not dealing with a universal here. You are dealing with a conditional, so it is important to approach the problem in the right way. If you do something like this, you're not going to get credit. Okay, so here, again, the first question is, what kind of a statement do we have here? Well, look, we have an existential this time, because this is the existential, and this whole thing is in the scope of the, sorry, this is a universal, and the whole thing is in the scope of the universal. So we are dealing with a universal, right? Whereas here, we are dealing with a conditional. Okay, now that we are dealing with a universal, in order to determine the truth value of the universal, we want to know whether the universal, the thing in the box here, is true of every object in the domain, right? So because that's how we determine the truth value of the universal. So let's start with object 1. We want to know whether the thing in the box is true of object 1. So let's treat x as referring to object 1. Here is what we get. hx1 arrow, there is some y, jx1 and iy. Notice that we don't treat y as referring to anything, because y is not a free variable, it's in the scope of this existential. So we just treat x as referring to something, because x is a free variable. Okay, now is this thing true? Let's find out. So hx1 is true. 1 is in the extension of h. Now the question is whether this thing is true. So notice that here we are dealing with a conditional. Again, we need to know the truth value of the antecedent and the consequent. Okay, now the consequent in this case is an existential, right? So it is true if there is at least one thing that satisfies this thing in the box. So let's find out if there is at least one thing that satisfies the thing in the box. Let's start with object 1. So if you eliminate there is some y, and then you treat y as referring to 1, you get this jx1, jx1 and iy1. Then we need to check for object 2, and that's what we get. Again, eliminate for all y, what is for some y, and what is left is jx1 and iy, this time referring to 2, and then you get and then you get jx1 and iy referring to 3. So we need to know whether any of these things is true. If any of them is true, then the existential is going to be true. Okay, how about the first one? Well, notice that 1 is not in the extension of I, so iy1 is going to be false. And that is enough to make the whole thing false. 2 is not in the extension of y either, so iy2 is false, and that is enough to make the whole conjunction false. Now object 3 is in the extension of y, so iy3 is true. And jx1 we know that is true because here we have 1 is in the extension of j, so true and true gives us true. Okay, so there is at least one object that satisfies the thing in the box. So the existential is going to be true because of this one object. So true, error, true gives us true. Right? So notice that object 1 satisfies the thing in the box for this universal, right? But that is not enough to tell us whether the universal is true or false. because universal is true if everything satisfies the thing in the box. So now we move to object 2. Let's see if object 2 satisfies the thing in the box. So I'm going to write it here. So hx2 arrow, there is some y, jx2 and iy. Okay, so hx2 is true. How about this thing here, the consequent? Again, the question is that, is there anything that satisfies the thing in the box? Because here in this box, because here we are dealing with an existential, and as long as one thing satisfies this thing in the box, the existential is going to be true. However, notice that jx2 is false, right? Because 2 is not in the extension of j. So you kind of already know that nothing could satisfy the thing in the box, right? But you need to show that. So let's just write things down. So first the question is whether object 1 satisfies the thing in the box. So we're going to get jx2 and jx2 and iy referring to 1. Then we get jx2 and iy referring to 2. Then we get jx2 and iy referring to 3. And we know that all of them is going to be false because jx2 is false. Okay, now that we have shown that everything fails to satisfy the thing in the box, we can say that, well, the existential is going to be false. And that's how we show it with these diagrams. Okay, true arrow false gives us false. So what we have here is that object 2 fails to satisfy the thing in the box for the universal. So let me get this out of the way. So what does that tell us about the universal? Well, it tells us that the universal is going to be false. We don't need to check object 3 because as long as there is at least one thing that fails to satisfy the thing in the box, the universal is going to be false. So because of this, the universal is going to be false. Okay, so you need to do these diagrams in order to present your thinking, your solution. So let's see how we're doing on time. Well, let me just do one more. Okay, this one involves double quantifiers. So let's see what's going on here. So the same interpretation, a different statement, we approach it in the same way. You want to know what kind of a statement you are dealing with. And here you're dealing with a universal, kind of everything is in the scope of this universals, right? So the statement here is a universal. Okay, so now, since the statement is a universal, the question is that whether it is the case that everything satisfies this thing in the box. So let's see. So you eliminate the universal and then you treat x as 3 referring to 1, and then you treat it as referring to 2 and then 3. Okay, so here is what we get. Eliminate the universal, you get there is some y, f, x treated as referring to 1, arrow, h, x as referring to 1, or jy. So we don't treat y as referring to anything just yet because y is in the scope of this quantifier. Y is not a free variable. Okay, so we want to know whether this thing is true or false, whether object 1 satisfies the thing in the box. And now this thing is an existential statement. itself. So the question now for us is that whether there is something that satisfies, sorry, what happened? So whether there is something that satisfies the thing in the box here. Let me just draw a box. Okay. So in order to do that, we eliminate there is some y and then treat y as referring to 1, 2, 3. Okay, so let's do that. We get this. We get fx1 arrow h x1 or jy1. Then we treat y as referring to 2. We get fx2 arrow hx2 or jy2. Then, sorry, fx1 should be fx1 and also hx1. That doesn't change. We are checking for whether something satisfies the thing in the box here, so we need to deal with y. And then we treat y as referring to 3, so we get fx1 arrow hx1 or jy3. Okay, now the question is whether any of these is going to be true. So we know that fx1 is true. We know that hx1 is true. So we know that this whole disjunction is going to be true no matter what jy1 is, and true or true gives us true, right? And that is really enough to make the existential true, because the existential is true if there is at least one thing that satisfies this thing in the box here. And there is this thing that satisfies it. So because of this being true, the existential is going to be true, right? So we don't really need to check the other ones. We don't really need to have them. I just did this as a practice. But as long as you get something that is true, you can stop with the existential. So let me just eliminate these other ones that we don't need in order to get them out of the way. Okay, so now we know that object 1 satisfies this thing in the box in front of the universal, right? But that is not enough to make the universal true. We need to keep going. So the question now is whether object 2 satisfies it. So let's check this one. There's some y, and then we treat x as referring to 2, fx2 arrow hx2 or jy. Okay, now again, we are dealing with this existential, so we want to see whether there is anything that satisfies this formula. So we eliminate the existential and treat y as referring to the objects in the domain. And again, you will see that the first one is going to be true, so let's do that. fx2 arrow hx2 or j. Now you treat y as referring to 1. So is this thing true? Well, fx2 is true, and also hx2 is true, right? So true, true. So this whole thing is going to be true. True, error, true gives us true. We don't need to check other objects, 2 and 3, because there is at least one object that satisfies this thing. So the existential is going to be true. Okay, so what we have here is that it turns out that object 2 also satisfies this thing in the box. But we are not done yet. For the universal to be true, we need to have everything satisfying the thing in the box. So let's see if object 3 does that. So this time we treat x as referring to 3, and here's what we get. There's some y, fx3 arrow hx3 or jy. Right? Now again, this is an existential, so the question is there, is there anything that it satisfies this thing here? Okay, so let's start with object 1. So now we eliminate there is some y and replace y with 1. And here is what we get. fx3 arrow hx3 or jy1. So what's the truth value of this? Well, again, if you look at the thing that at the interpretation, fx3 is true, hx3 is false, but jy1 is true. So here's what we have. True, false, true. Since this is true, jy1, the whole thing here is going to be true. True, error, true gives us true. So object 1 satisfies the existential. So the existential is going to be true. We don't need to check the rest of them. Okay, now look at the situation that we have here. Here we see that object 1 satisfies this thing in the box, the box in front of the universal. Here we see that object 2 satisfies the thing, and here we see that object 3 satisfies the thing in the box. So as it turns out, everything satisfies the thing in the box here. So the universal is going to be true. And the way that you show it is that you show that everything here kind of satisfies the universal. So this one is true, this one is true, and also this one is true. So because of all of this together, the universal is going to be true. Okay? So things can get complicated, but as long as you keep track of what you're doing, what sentence you're dealing with, you can do the problems. They're not that difficult. Okay, so let's stop here. We will do some more problems next week.